recording audio, but I'm just going to act like it's recording about right now, and we'll see how it sounds. Okay? So here I have done the first step. Whenever they give you a function, boys and girls, they're going to give you a function and say find the inverse. Your first step is just to replace the function notation with a y, and that's what I've done right here. Everybody can remember that, yeah? Everybody say yes.
Yes.
Okay. So now, what's the next step to find an inverse? Same thing we did in topic 4. What do? We swap the x and y. We already discovered earlier in the lesson that everything about inverses, domain and range swap, so that means we swap the x and y. So I'm literally going to do that first right here. I'm just going to rewrite the x and the y in different places. Now, something that is weird about this skill that's kind of different than it was in topic 4 is I can't convert yet. I can't isolate y yet. I've got to make sure I isolate the log piece. I can't convert to exponential until I get rid of this 1. So I only have to add 1 to the other side. That's the only piece that is weird here. Okay? Now I convert. Remember what I said when we convert. We switch the bases and then switch the sides. Let's see if that works, because these are on the wrong side. These are on the wrong side of equal sign. So what's the base right here, boys and girls? Nope. It's e. Natural log is always base e. So I'm going to say base e, and because this is on the different side, it's e to the x plus 1. Remember, a logarithm is an exponent, so that's the exponent. E to the x1 plus 1 power equals y plus 3. So let's see that in action. E is the base. You always start at the base because the base is the base is the base. E underneath the equal sign to this power, and then loop it to that side. You see how we convert bases and we swap sides? We swap sides because I brought the e to the left side. That's the only reason it looks weird. Now, continue to isolate y. What's the last thing we do? Subtract 3. So there's our inverse. We can write this in function notation. We can just say f inverse of x equals this stuff right here. All right? Would you guys like to see the same thing but starting from the other method right there? Everybody say yes.
Yes. Yeah.
What's the first thing I do? What do I do for this function notation right here? Yeah, just make it a y. So y equals this stuff. Is this isolated? Is this ready to convert? Everybody say yes.
Yes.
Oh, wait. Sorry. I forgot the first step. I got to swap x and y first. X equals 4 to the y plus 5. Now can we convert this? Yeah, we sure can. If I'm going to switch the bases, so I'm going to start with log of 4, and then if it starts to 4, go under the equal sign. Log base 4 of x equals, loop it, y plus 5. And now what's the last step? Piece of cake. Subtract 5. Very good. Log base 4 of x minus 5 equals the y, so that's our inverse for g. Now, I'll say it on the video because it's super, super important for you guys to see this. Remember how inverses swap domain and ranges? Check this out. Look at the original function. Isn't this an h? Doesn't that move left 3 and down 1? But look at the inverse. Look what happens to the inverse. Doesn't this mean this moves left 1 and down 3? Look how the horizontal and vertical shifts, they swap places. That happens for inverses. Same thing over here. Doesn't this say that we move the whole exponential left 5? But what happens for the inverse? It looks like it moves the logarithm down 5. So again, there's a great illustration of how inverses work and how they swap domains and ranges. That was a